Hi, this video is the second on the sketch method of three. This one is on finding the x and y intercepts. So, what we're going to look at, learning to sketch linear, quadratic, cubic and quartic functions using the sketch method. Now, after this video you should be able to expand and factorize functions using your CAS calculator, explain which form helps you find the y-intercept more easily and which one helps you find the x-intercepts, or roots or zeros. Recognise and calculate the y-intercept, recognise and calculate the x-intercepts or zeros, and also describe what effect a double or triple zero has, and describe what effect a factor of just x has. So you'll see what I mean by this in a couple of minutes. Now, assumed knowledge here is that you already know how to find the dominant term and identify the basic shape of a function. If not, go back and look at the first video in this series. So we're going to start off by expanding and factorising and finding intercepts. So the first thing we need to be able to do is make sure we can expand and factorise. Now, in this case, I'm just going to be assuming you're using your calculator to do this. If we wanted to look at the algebra of that, we'd have to look at a different video. So, let's say you were only given this. You were only given this form here where it's already been factorised. If you go to interactive transformation expand and put in x plus 1, x plus 2 and x minus 5 and say OK, you see that we get the x cubed minus 2x squared minus 13x minus 10, which is what we have here. So it's identical. This expression and this expression are identical. If we were then to work backwards, if we were, say, only given this one, we would factorise to find this one. And the reason it's useful to have both is because, well, you'll see in a minute, we can get different information from the different forms. So if we factorise x cubed minus 2x squared minus 13x minus 10, you see it gives us x plus 2, x plus 1 and x minus 5. Doesn't matter what order they're in, it's just three things multiplied together. Okay, so when we're looking at this now, we know from our previous video this is going to be, the basic shape of this is going to be a positive cubic, which means it's going to look like that. Now there's a few possibilities here. A positive cubic may do something like this, in which case you can see it crosses the x-axis once, crosses the y-axis once, and then just doesn't come down far enough to cross it again and goes up, keeps going up. Or another possibility is it may go up, come down, and just bounce off in effect, just like once like that. So it crosses here, or kind of goes in and out, and crosses here once. And another possibility would be that it might go up and down and through. Now if you look at this one here, it's going through the x-axis 3 times and through the y-axis once. So the thing that all of these have in common is they all go through the y-axis once, and it doesn't matter how you move them around, up, down, left, right, they'll only go through the y-axis once. But they could go through the x-axis 1, 2 or 3 times. And what it looks like when it's factorised will help us determine that. Okay, now if you go to your graphing option and we put this in, I've just put it in this form, but it wouldn't matter if I put it in this or this, it's the same function, and then graph this, we can see this one is going through the x-axis 3 times and it's going through the y-axis once, and we want to work out what those values are. Now if you have a look here at the y-axis first, the place that it crosses here is when the x value is equal to 0. So when x equals 0, y equals something. So if we set x equal to 0, we can find out what the y-intercept is. Now the easiest way to do that is when it's in this form, and that's because if x equals 0, then this would be 0, this whole thing would be 0, this whole thing would be 0, and we would be left with y equals negative 10. So it's kind of easy to just read off, to read off the y-intercept when it's expanded. It'll be the constant, the number right at the very end. But we should always write this in as part of our working. Y-intercept when x equals 0, so y equals 0 minus 0 minus 0 minus 10, so y equals negative 10. That means we know exactly where it's going to cross over here. I'll just get rid of these for a second. And put it in here. So it's going to cross at negative 10 there. Now the x-intercepts are when y equals 0, which you can see if you have a look here. when the y value comes down to 0, that's where it crosses the x-axis. So we need to solve a different problem. We need to solve when y equals 0, which means that the top version makes it a bit easier, the factorised version. So if we have 0 equals x plus 1, x plus 2, and x minus 5, when it's factorised like this, it means that if you have three things multiplied together that make 0, at least one of those things must equal 0. So we've simplified the problem. It means x plus 1 equals 0, or x plus 2 equals 0, or x minus 5 equals 0. And if that's the case, x equals negative 1, x equals negative 2, or x equals 5. And there we've found our three intercepts. They're at negative 1, negative 2, and 5, which you can see here. There we go, negative 1, negative 2, and 5. That gives us enough information to be able to sketch it. The only thing we should do here is make sure that on the axis it's roughly to scale. As you can see, this distance here to 10 doesn't have to be the same as this distance here, and then we would be able to draw in coming down like that and going back up there. Alright, and we're going to look at how we lay our working out in the next video, so we tie it all together. But there's a couple of other things I want to show you first. This one here is the effect of a double bracket, or a double zero. So we've got x minus 1 and x plus 2 squared. Now another way to write that would be like this, x minus 1, x plus 2, and it means it's times by x plus 2 again, like that. So y-intercepts when x equals 0. When x equals 0, this form is useful, and we make x equals 0, y is equal to 0 plus 0 minus 4, so y equals negative 4, means I know it goes through here. The x-intercepts are when y equals 0, so it helps to have it expanded like this, and I get y equals x minus 1, x plus 2, x plus 2, set y equal to 0, so 0 equals that, and then that means x minus 1 is equal to 0, x plus 2 is equal to 0. I've got the same thing here again, x plus 2 equals 0. So what we're going to get is what we call a repeated solution, or a repeated root, or repeated 0. This means that x equals 1, x equals negative 2, and I'm going to get x equals negative 2 again. And what that means is that I'll have a value here for 1, and at negative 2 I'm going to get that bouncing effect. It's going to go in and out. Now because I know that the basic shape of this is this, a positive cubic, it's going to have to come up here, bounce off there, come down and up. Now actually it's probably would be better if I bounced it off there, came down and went up like that, but you can check it on your calculator to see which side exactly the turning point should go on, which side of the axis it should go on. My guess would be there. Alright, now another thing, what if we have it happening 3 times? This is like a triple 0. Well, we've got the same sort of thing going on here, x plus 2, x plus 2, x plus 2. So y-intercepts when x equals 0, we can see it's going to be negative 8. X-intercepts are going to be, or we'll have from this, 0 equals x minus 1, x plus 2, x plus 2, x plus 2. So basically what we get is that x equals 1 and negative 2, negative 2, negative 2. We get 3 lots of negative 2. So it's going to go through here, negative 2. It's going to go through here at 1. The basic shape we know is going to be a positive quartic, which is going to look like that. So what's going to happen is it's going to come down here, and we're going to get, instead of it bouncing off, it can't bounce off, so it has to come through, but it changes shape like that. So this is what's called a point of inflection. So it comes down like that, and then it's going to turn, and it's going to go up through there. So you get your point of inflection here. So it does go in and out, but not just in a straight kind of curve like that. It changes direction a bit like that. Okay. So that's the effect of a triple 0. Now the final thing is what happens if you have just an x here. Now there's a few ways you could look at that. One way is to think of it as being, you can have the minus just on the outside here, and you can think of it as being almost x minus 0. if you like. You don't have to think of it this way, but some people find it helpful. So the y-intercept when x equals 0, it's interesting, there is no number here. There's nothing at the end here. So if we make x 0, you get 0, 0, 0, leaves you with nothing. So when the y-intercept when x equals 0, y equals 0. It means it goes through the origin 0, 0. That always happens there. So that's something you know straight away. This is a negative cubic, so we know it's going to be like that. We know it's going to go through there. So we've actually already found one of our x-intercepts, which is this one. So this one is telling you that it's going to go through 0, which is what this bracket tells us. And we also know we've got x plus 2 and x minus 3 giving us x is equal to negative 2 and positive 3. So it's going to go through here, negative 2 and positive 3 down here. This is a negative cubic, so it's going to come down like this, up like that, and down like that. Okay, so that effect of the x, that single x, means that it's going to go through the origin like that, and you've already found the y-intercept in effect. Okay, so to recap, to find the y-intercept you need to set x equal to 0 and solve, and write that down. To find the x-intercept you need to set y equal to 0 and solve. The expanded form makes it easy to see the y-intercept because it's the last value, the last constant. The factorised form makes it easy to find the zeros. Double zeros bounce off. Triple zeros pass through in a point of inflection like that, or if it's going up like that. And a factor of just x means it will go through the origin 0, 0, so that the y-intercept is therefore also 0. Okay, in video 3 we'll look at putting it all together so that we can sketch our functions.